Now that we've covered the basics of deductive reasoning in general and the properties of sentences and sets of sentences, it's time to get into the main focus of this course, which is arguments. So the anatomy of deductive arguments is pretty simple. You have at least one premise, usually more than one, and then the conclusion that the premises are supposed to prove. Here's the classic philosophy example. All humans are mortal. Socrates is a human, thus Socrates is mortal. The first two sentences are the premises. The claim Socrates is mortal is the conclusion. The word thus at the beginning of that sentence helps indicate that it's a conclusion. Other conclusion indicator words are therefore and so. For a more comprehensive list of conclusion and premise indicator expressions, if you're worried about being able to pick these out, see page 6 of the logic book. So while actual arguments are usually made in paragraph form, in philosophy and logic in particular, we display them in particular ways. And the first is called standard form. The premises are laid out first, one on each line above each other, and then the conclusion is below, separated by a solid line. In the course, you'll often see arguments in standard form, both in class and in the textbook. The other way you'll see arguments presented is using the set notation. The premises will be inside the set brackets, separated by a comma. After the set of premises, there's this turnstile symbol, which symbolizes entailment, followed by the conclusion. You'll see problems in the textbook like this, and on exams. So in this format, you'll see it. And this says this set of sentences entails this other sentence. That's one way to say this is an argument. So now that we've gotten the basic formatting out of the way, let's get into validity, which we talked about very briefly when we talked about entailment in the last video. Validity is the property of arguments that captures truth preservation. The definition of validity is as follows. An argument is logically valid if and only if it is not possible for all of the premises to be true and the conclusion to be false at the same time. And this definition allows us to rule out that you'd be able to get a false conclusion from true premises. It's important to remember here that just like with the other logical properties covered in the last video, validity is not concerned with whether the premises of the argument are actually true. With validity, we're focused entirely here on the structure of the argument and the relationship between the premises and the conclusion. So in asking if something is valid, you make the premises true, you assume they're true, and then ask whether the conclusion follows from that. So here's two examples. The first has two premises, all dogs are scaly and sugar is a dog, and then the conclusion, sugar is scaly. Don't let the fact that the first premise is obviously false distract you. Look at the argument and ask yourself, if the premises are true, is it possible for that conclusion to be false? And the answer is no, right? This is a valid argument with the exact same structure as the classic example of a valid deductive argument about Socrates from the slide before, right? All humans are mortal. Socrates is a human, so Socrates is mortal. All dogs are scaly. Sugar is a dog, so sugar is scaly. This is a valid argument. Now let's take a look at the second example. The two premises are all dogs have fur and Cupcake has fur. Pretend that both of these premises are true. Is it possible that the conclusion that Cupcake is a dog could be false? Is it possible? And yes, of course, it could be false, right? Cupcake could be a cat or a bear, or even if it is true that all dogs have fur and Cupcake also has fur. So even though in this case, both of the premises and the conclusion are actually true, it's still an invalid argument because we're only looking at the structure and whether it necessitates the truth of the conclusion, not the actual truth value of the statements involved. So even though this has true premises and it actually has a true conclusion, it's still a bad argument. Now, based on the first example on the last slide, it's obvious that validity by itself is not enough for us to call any deductive argument a good argument, right? Because then we would have to accept that sugar being a scaly dog is a good argument. So deductive arguments must be valid and they have to have all true premises. And these are called sound arguments. This rules out the valid argument from the last slide, right? Because the premise, all dogs are scaly, is false. So that argument is unsound and a bad argument. Note that an invalid argument is automatically unsound, regardless of whether or not that argument has true premises. So the cupcake argument from the last slide is also invalid, and because it's invalid, it's unsound. So next we're going to talk about some weird some weird counterintuitive answers that we get from this technical definition of validity. So first, and this is very similar to the special case we looked at in the last video with entailment, an argument with a logically true conclusion is always valid, no matter what the premises are. And this is because it's impossible for the logically true conclusion to be false, right? So that satisfies the definition of validity, that it's impossible for the premises to be true and the conclusion to be false at the same time. That second part, that it's impossible for the conclusion to be false while the premises are true, is automatically satisfied. So here's an example. The moon is made of cheese. The sky is red. Therefore, it will either rain tomorrow or it is not the case that it will rain tomorrow. Now, that conclusion is logically true, right? Which makes this a valid argument because it's impossible for that conclusion to be false. So it's impossible for the conclusion to be false and the premises to be true at the same time, even though the premises are wildly unrelated and both false, right? The consolation is that this type of counterintuitive case is that it's easily recognizable as an argument in which the premises don't actually support the conclusion, right? We look at this and we can tell that it's not actually a good argument. So we call this trivial validity. It's valid, but we know that it's not actually a good, structurally useful argument for what we want to do with logic. The other counterintuitive case of validity is that an argument with logically inconsistent premises is always valid. So if the premises are an inconsistent set, then it's impossible for all of the premises to be true at the same time. This means that the definition of validity is satisfied, right? Because you can't find any possibility in which all the premises are true and the conclusion is false, no matter what the conclusion is, even if it's false, because that first part, that you have to find a possibility in which all the premises are true and the conclusion is false, is satisfied. So here's an example. Cupcake is a dog. It is not the case that Cupcake is a dog and lizard people control world governments, right? This is a valid argument because we're never going to be able to find a case in which Cupcake is a dog and it is not the case that Cupcake is a dog are both true and the conclusion is false, right? So clearly a very bad argument, but still a valid one. And the upside of these weird cases is that this type of argument can never be sound, right? We're never going to have an argument with a logically inconsistent set of premises that has all true premises. So we can recognize it as an unsound bad argument, even though it does, get that stamp of validity from our technical definition. So now let's do a quick recap of what we've covered so far in the last two videos, right? So these are the properties that apply to these different types of things, right? So individual sentences can be true or false in their relation to the actual world, their actual value. They can be logically true, false, or indeterminate, which is based on their structure and the possible truth values, not just what's actually true in the world. Sets of sentences can be consistent or inconsistent, which depends on whether it's logically possible for them all to be true at the same time. Pairs or sets of sentences are equivalent if it is impossible for one to be true while the other is false, meaning they have the same truth values. and they're inequivalent if it's possible for their truth values to differ. A set of sentences entails another in sentence if it's possible for the set to be true, if it's impossible for the set to be true and that other sentence to be false at the same time, which is very similar to this definition of validity, right? It's almost an identical definition, that it's impossible for the premises to all be true and the conclusion to be false at the same time. That's what makes an argument valid. If it's possible to have all true premises and a false conclusion, then that argument is invalid. The distinction between entailment and validity to remember here is that validity applies only to arguments. You can't say that a sentence or a statement or a set of sentences are valid. Validity only applies to arguments, where entailment applies a bit more broadly. And the last property is soundness. This is the benchmark of a good deductive argument. It is both valid and it has all true premises. All right, so now we've gone through all the basics of deductive logic and deductive reasoning that you need to get started in this class before we start working with a particular system. Let's go ahead and talk about what to look for if you're still a little confused or just want to review. This is on the course schedule as well, but all of the material I've covered in these two videos is in pages 1 through 14 of the logic book. And it's also covered in Course Manual Lesson 1. We won't be using the course manual a lot directly in this class, but it's a really helpful resource created by Dr. Rawling as another way of approaching this material. So I recommend you look at both of those. You're also welcome to do some practice problems. There's not very many in this section. There's a few on page 14. The ones without stars by them, the ones that are unstarred, have solutions in the solutions guide, which is available at the link in the syllabus and also available directly through the Canvas site. I have them uploaded under that course documents section next to the pages of the logic book themselves. So that's all that we have for today. That's where you should look for more information, and I will see you in class.